Hi guys, my name is Laura Treese. I'm one of the chemistry teachers at Heritage High School, and today I'm going to walk you guys through how to do scientific notation and reading instruments. This video shouldn't be very long, but to complete it, you definitely want to have something to write with and something to write on, and that's it. Okay, let's get started. Okay, so we use scientific notation basically as a way to write cumbersome numbers, and I love that word, cumbersome. Basically what we're really looking at is numbers that are way too big or way too small to be written in just normal form. They're just unmanageable and not fun to write. And one of the main reasons we use this and the main ways we use this is when we are talking about the number of atoms in something. And so for that, our conversion is going to be called the mole. So 1 mole. You guys will hear about moles all year long, and it's super fun. 1 mole is 6.02 times 10 to the 23rd. Okay, so if I wrote that out in normal, standard notation, it would look like this. All right, and it's going to take me a hot second to write this too, so I'm really sorry. Boom. Okay, that's a really big number. Okay, and I don't know about you, but like personally, I would much rather write this out versus that long number right there. Okay, so that's what we use scientific notation for. And there are some exceptions when we don't use scientific notation. So there's 4 places you never use it. You don't ever use it for temperature, money, molecular masses, or pH. All right, you guys probably know what temperature and money are. We'll learn about molar masses pretty soon, and then we'll learn about pHs next semester. But yeah, scientific notation is written out in this formula, right? That's down here, A times 10 to the B, where A is our mantissa, and our mantissa is basically just a number that is between 1 and 10, and B is our characteristic, and this just tells me basically the number of decimal places that I move. All right. And our characteristic can be positive or negative. So if it's positive, it shows that we have to go to the right. So anytime we have a positive exponent, I always think it's a number bigger than 1. All right. And then if I have a negative exponent, it goes that many places to the left. So a negative exponent tells me that my number is smaller than 1. It's a decimal. So bigger than 1, positive exponent. Smaller than 1, negative exponent. All right? So let's do some practice with this. I'm going to zoom in. All right, and I'm going to start with the first one. So our first one says 306.43. Okay, so step 1 is to get it to be a number between 1 and 10. So if I was going to put my decimal somewhere, I'd put it right there to get it to be a number between 1 and 2, but 10 between a 3 and a 0. So I get 3.0643. That's my mantissa. And I know it's going to be times 10 to some power. So to figure out my power, I have to see how many decimal places I moved. I went 1, 2. My number is bigger than 1, so it's going to be a positive exponent. So I get 3.0643 times 10 to the second power. Okay, same thing down here. All right, where do I need to put my decimal to get a number between 1 and 10? After the 5. So I get negative 5 times 10, and then how many times do I move my decimal? 1, 2, so negative 5 times 10 to the second power. All right, one more, and I'm putting it into scientific notation, and then I'm going to do a couple taking it out, leave the rest for you guys to do as practice. Okay, so once again, I've got my number, and I need to figure out where I put my decimal. So I'm going to put it between the 1 and the 4. So then I get 1.4286 times 10. How many times did I have to move my decimal? 1, 2, 3, 4. and that number is a decimal, so that means my exponent is going to be negative. So I get 1.4286 times 10 to the negative 4. Okay, now then there's about 3 practice problems for you guys to do to put it into scientific notation right there. So I want you guys to definitely work through those and practice on that really quickly. Go ahead and pause the video right here. And when you come back, I'll have the answers for you guys. Okay, so pause the video. Hey, hope you did your practice problems. So for the first one, I got 5.3, negative 5.3 times 10 to the 5th. Second one, I got 7.2 times 10 to the 7th. And then for the last one, I got 6.14 times 10 to the negative 6th. All right. Now we're going to do a couple practice problems of taking them out of scientific notation. Then we'll do reading instruments, and then we're done. Yay! Okay, so for this first one, I have 3 times 10 to the 2nd. All right, it's 2, so that tells me I'm moving 2 spaces, and it's positive, so I'm moving 2 spaces to the right. So I have 3, my decimal right there, going to move 1, 2, fill in with zeros, so I get that right there my answer is 300, not written in scientific notation. Then for the next one, I have negative 4.28 times 10 to the 3rd. All right, again, moving 3 spaces, positive, so I'm moving 3 spaces to the right. So I get negative 4.28, moving 1, 2, 3, fill in with zeros, so I got negative 4,280. Just wrote that 8 really weird. I don't know why. And our last one, 7.51 times 10 to the negative 9th. Okay, so I'm moving 9 spaces and it's negative. So this time I'm moving to the left. So 7.51, moving 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill in with zeros, and I got 0.000000751. Should be 7 zeros. Okay, that's scientific notation, guys. There'll be a practice posted on Canvas for you guys to go through scientific notation. Then we're just going to go through reading instruments really quickly, and we're done. Okay, guys, so reading instruments in the lab is really important to know. It's important to know how many places we are going to read our lab equipment. So it says it's important to know how many decimal places, if any, to measure to. All right, we always keep our sig figs, and we're going to talk about sig figs. It's coming. But significant figures are basically what we read to in science. So it's important to have those significant figures because it tells us how accurate our measurements are. All right, so when we are reading lab equipment, we always read 1 decimal place further than the equipment has marked. So always add 1, we always say add 1 digit of uncertainty, so kind of guesstimating your last digit. So let me show you guys what I mean by reading these next few lab equipments. So these are burettes, and you guys can tell because the volume goes up as we go down in our volume. So we read them from top to bottom if it's a burette. And then if it goes up from like lower to higher, that's like a normal graduated cylinder. Burette goes from lower to higher opposite. That was kind of a hot mess explanation. But so for this one, basically, things I need to look at is what does each line represent? So on this one, each line here represents 1/10. All right, so I'm going to read what I for sure know. So I know I have 6, and I have 6.6, just because that's the line we're at. And then I'm going to get my 1 digit of uncertainty. So 6.6, guesstimate that last number. I'm going to say 2. So 6.62 milliliters, because we have to have that digit of uncertainty. Okay, kind of the same thing over here. Again, it's a burette because our numbers are increasing as it goes down. So for this one, again, we're going to read kind of the same way. So I have 23, and I know I have 23.4. Those are my definite numbers. And then my last number is a guesstimate. So 23.45. Okay. And then this one is a graduated cylinder because our numbers are going up. So this one is 2.6, and then kind of a digit of uncertainty. I'm going to say 2.64 because it's a guesstimated last number. Sorry, my stylus messed up. Milliliters. Both of those are milliliters. Okay. And same thing with our rulers. So for our rulers, we're still going to guesstimate to one digit of uncertainty. So I know I have 6, just because the next number is 7. So I have 6. Each line represents a tenth. So I have 6.8, and then digit of uncertainty. I feel like it's right on that line. So I'm going to say 6.80 would be my digit of uncertainty there. And then last one. 3 is our first number. Each line represents a tenth, so 3.2. Then again, I feel like it's right on the line again, so I'm going to say 3.20. But reading to one extra digit than what is physically marked on my equipment. So make sure you guys are doing that, okay? All right. Hopefully this was a helpful video. There's practice posted on Canvas for y'all to complete. Bye.